Oh, I've been yapping this whole time and my microphone was off. Um, ay, ay, ay. Good morning, Noel. No sound? Is there sound now? How laggy? How far behind am I? Please let me know if there's sound now. Yeah, by rapid fire, I just mean I'm tired of reading this in detail, and so we're going to quickly scroll through the book to some cool theorems. Now there is sound. Okay, great. Yeah, so that's what I mean by rapid fire today. And then I think tomorrow we'll just have like normal office hours where I talk about random bullshit. And maybe we go look at archive, and maybe we go look at Reddit. Yeah. Every central division algebra. Yeah, see, I'm just not even... from 1 to 100 in percent, how well do I understand these notes? 20. I mean, I feel like the sections that we've gone over, I feel like I understand them decently well. Like I've said, I need to just go back and redo and like do a bunch of exercises, but doom scrolling live stream, yeah. Well, I mean, isn't that what all my live streams are? Except we just doom scroll math instead of Instagram or something. Yeah, like I don't want to read the details of this, but one day I want to sit down and use the cocycles to compute some Brouwer groups. Yeah. But let's just skip ahead to the exciting answer. I think I saw something about Brouwer groups of p-adic fields. Archive should allow comments and become a blog? Actually, maybe that's not a terrible idea. Maybe it's not a terrible idea to have somewhere. Yeah. I don't know. Your paper sucks 0 to 5. Yeah. Does archive really need a comment section? I don't know. I mean, I like yapping about math, but I wouldn't. I don't know if I'd want to feel like the obligation to reply to people. And I think mathematicians already do this. Like when my last preprint came out, pretty soon after, I got some comments from someone who just emailed me. So, yeah. Every finite, yeah. Okay. So, for example, the Brouwer group I guess I should say the relative Brouwer group of the complex numbers over the reals is just Z mod 2. True, it's not public, but I don't know. Does it really need to be? Like, how many people in the world need to see like the niche discussion between like me and one other researcher? Like there's a very small handful of people in this specific thing. I don't know if it's that useful for the rest of the world. Pros and cons of getting a pet in grad school. You only see cons, yeah. I don't know, something serotonin, Cat purrs have been shown to be antidepressant. Source, you made it up. Well, I trust you, Boris, because you're funny. Yeah, I don't know. I almost in my master's during the pandemic started taking care of dogs on weekends. But I didn't have my own car, and they said I needed my own car. I couldn't just use my roommate's, so. Yeah, exactly. There's enough platforms to do it on. Right, and so the non-zero element of this group is represented by the quaternions, which is pretty cool. What about non-Archimedean local fields? This looks crazier. It's the entire group Q mod Z. Fascinating. I mean, I guess that makes... Well, I don't know. I guess it makes sense. I guess you would expect roughly, because it's further away from being algebraically closed than the real numbers are. And I guess it tracks from a vibes-based perspective. And they even show an explicit way how to build this up. I mean, this is probably something I do need to pay attention to at some point. Because I guess this is relevant for what we were talking about before, about how there's all of these versions of Langlands, or one can do all of this stuff for so-called other forms. I think even the division algebra case are inner forms, and comment section on archive would become like our number theory. And anyways, it's maybe something worth venturing into is like GLN over a division algebra. I know people work on it. Yeah, I mean, I would imagine Tao's blog has pretty, would have a lot of crackpots flying into it. And Category Cafe, maybe not as much. Just because it's a little more niche. Like, that's more... Like, Terry Tao is a very public-facing, famous person. So... it's easier for crackpots to catch wind of him and go flood his blog. You'd be happy with anything that would get us putting our hands on explicit examples? Wait, you mean in terms of what we're reading today? Yeah, maybe it's not a bad idea. I mean, one thing I kind of want to do, but I kind of also dread doing it, would be to go look at there's this book by Bushnell and Kutsko, The Admissible Dual of GLN by Compact Opens, and basically they like construct all the you mean in terms of central simple algebras and Brauer groups in general? Yeah. I guess what would be a good computation? I guess this one maybe. Well, maybe I'll put this on my to-do list eventually, because today's just about wrapping up loose ends here, scrolling quickly through the chapter, and then we're returning to regular office hours for a little bit. Oh, an infinitist. A new philosophy of mathematics just dropped. I mean, here's this example. We can stare at this example, but already it looks so if we take the unique unramified extension of degree n, and we look at Frobenius. Okay, the claim is that our two cocycles. Oh, and we take this particular two cocycle. Okay, this is true as expected. And then what? Wait, I thought they were going to build the algebra for us. Oh no, that's what's happening. Oh, the cross product. Ah, I see. The cross product. Okay, they are building the algebra. So the algebra, I guess, has dimension equal to the degree with this multiplication. Yeah, I don't know. What to say? What else to say about it? I guess it makes sense that this wouldn't be an algebra that we're used to. Well, Boris, maybe we're just seeing pieces of his messages that extend infinitely far into the future. I mean, there are people who take the legitimate stance, who would consider themselves finitists, and you could just drop the axiom of infinity. Plenty of things still work. Can I read over your crackpot paper? You have unified gravity and quantum mechanics. Well, maybe. You can send it to my email. And I'm thinking about doing more videos where I look over those papers. But I guess it depends. I guess it depends on the paper. I may or may not do it. You can definitely send me an email to your work, and we'll see. Yeah, Boris, yeah. But I mean, by your own admission, it's a crackpot paper, right? So you already know that it doesn't work, presumably. Or maybe you're asking me to get more eyes on it. I have had a number of emails since some of my videos about crackpots with people who are like, hey, I'm a crackpot. Can you please review my paper in a video? So I might do that. It's pretty good. Well, but how do you know it's pretty good? That's kind of a, right? Whether a paper is good or not is kind of a sociological question, and can only be answered, by the community of mathematicians. So that's a good question, Boris. I don't know why we call crackpots. I should charge money for that? I mean, I suppose I should. I mean, technically, I do make money from my videos. It isn't a lot. It's not compared to tutoring. But if you think about it, I do charge, a bunch of money. Like, I charge by the hour for tutoring. I tutor a lot of people, so, I mean, reviewing crackpot papers, maybe I should charge money. I don't know. That would be crazy if the channel then got really big. Yeah. Well, I think Yeah. I look like an INTP. Am I an INTP? I don't know. Well, I look like an INTP. Are we doing what's that called? Physiognomy? Physiognomy of the big four personality traits? I don't remember, to be honest. I've taken that test a bunch of times and I forget every time because I don't care. But every once in a while I'm like, yeah, what am I? What are my letters? Is it like pottery slander? Yeah, I mean, I guess it's just, yeah, you're just like, oh, that, you know, that guy's brain is dumb. Oh, his pot is cracked. I don't know. You could, wow, you're offering to pay me to review your paper. Okay. Sure. Then I'll say yeah. I mean, I can't promise. You may not like the outcome, though. I mean, before I look at it, I can't promise. I can promise you to give my honest take on it, but you may not be a fan of it. Well, I didn't know that there was any physiognomy of the personality types. So I'll take your word for it. Let's see. I think that you send the email later. This is just for publicity, okay. Okay. I mean, I guess they say that any publicity is good publicity, right? I can't... Oh, Brouwer groups and K-theory. Okay, we do got to read this a little bit. Yeah, I can't promise it'll come out very soon, and I wouldn't expect, payment until closer to the time, I suppose. Because I have a few other videos planned, and I want to be on like a weekly release schedule. But yeah, maybe within like a month, I will put up a video reviewing crackpot papers. Exactly, that's me. We gotta, yeah. I'm on the TV screen now. That's why we gotta read it. Okay. We've got a field with a primitive nth root to any elements in the to any non-zero elements. We can form this algebra. So I see. And this is a central simple algebra over K. The Milne K group, K2F of F, is the quotient of this tensor product by this relation. Okay, not exactly sure why. So it has these generators and relations. Wait, is this supposed to have something to do with this algebra? It's not difficult to show. Wait, why did he talk about the Milne K group in the middle of this? He introduces this algebra, okay. And then he talks about the Milne K group. Why? One for each pair of elements. It's just another group to attach to this? I don't know. Okay. It's not difficult to show that these algebras considered as elements of the Brouwer groups. Oh, I see. These elements satisfy the relations of the Milne K group. And so there's a well-defined homomorphism. It was proved in the early 80s that this map is actually an isomorphism from this thing onto the subgroup of the Brouwer group, killed by N. And so we have an explicit description of what is this notation supposed to mean, the thing killed by N in terms of generators and relations. This is a special case of the Bloch-Kato conjecture, since Galois cohomology is a Tal cohomology. I don't even, I've gone and looked it up a million times before. It's another thing I also always forget. I mean, that's the other thing, right? I'm just thinking in regard to Range Rover's request. I mean, it does me a service to, it helps me if I review these crackpot papers, because obviously I get a lot of views when I do it. But then I am platforming these crackpots, and then possibly Range Rover, I'm not necessarily saying that you would do this, but then they could also use it as ammo to be like, oh, look at these academics are just trying to silence us and they're hiding from the truth or something. But then again, they're going to do that anyway, so I don't know. It's the whole motivic cohomology stuff. There are two things that go under the name Bloch-Kato conjecture. Oh, okay. Okay. Basic theory of finite dimensional representations of groups. I like that. Might want to look up norm residue theorem. Norm residue theorem. Norm residue theorem, long sought, Milne K-theory, blah, 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 Milne, blah, 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 Voevodsky. What does it say? It says there's a map from K cross to here, to the Galois group, inducing this isomorphism. The first hint that this is related to K-theory is that K cross is K1 of K. Okay, I mean, in my opinion, this is very moonshine vibes, right? Or like, oh, this number plus one is equal to that number plus one. And it's like, therefore we generalize it. Like what? Every time I see the multiplicative group of a field, I should be thinking about the group K1 of the field. The first hint, it's related to K-theory? Like, what? What? Then, like, literally everything's related to K-theory. I mean, I guess you could say. I guess some people would believe that, but maybe on this channel I shouldn't be such a doubter and hater about possible relationships to K-theory, but okay, here we go. We got examples here. We got plenty of examples. We let the fields be the prime of which characteristic not equal to the prime of which we will not speak, and define the quaternion algebra in the obvious way. It is a central simple algebra over F. Nice. Oh, we have exercises. We could do some exercises, I guess. How much time we got left today? I mean, whenever I feel like ending stream, I guess, but maybe we should do some of these. Show that every four-dimensional central simple algebra over K is isomorphic to this. Okay. According to Wedderburn's theorem, this either splits as matrix algebra, or this is a division algebra. Show that the first case occurs if and only if this, and then this. Okay, yeah. Well, my initial thought on how to prove this would be just to take the most naive approach possible. I'm sure if I went back and reviewed everything that we've learned so far about CSAs, that there's a much easier slick proof to do this. But, okay, so what does it claim? Let A be a four-dimensional, let's see here, four-dimensional central simple algebra. Over K. Then A is isomorphic to the quaternion algebra, to some quaternion algebra. I squared is A, J squared is B. I squared is A, J squared is B. My Galois. Oh, yeah, got it. And then K is IJ, yeah. CSA is central simple algebra. Yeah, okay. Four-dimensional CSA. Where do we even start? Actually, I guess we start with the basis, right? Maybe. It's four-dimensional. E1, E2, E3, E4. Yeah, maybe the naive approach isn't so useful. Well, I mean, maybe we could start with this, and we get some arbitrary, we get some structure constants here, which would be, Mij, something like this. You successfully, can I say that on live stream? Probably. Will I get demonetized? Maybe I'll get demonetized. You screwed up a basic integral for an hour yesterday. Wow, that is rookie numbers. That is rookie numbers. Talk to me when you screw up a basic integral for an entire day. Then you're a real mathematician. Perhaps I can express the multiplication as a matrix and then show it's necessarily similar to the desired form. Good point, Arad. Good point. Yeah, so what would be the matrix of multiplication by I? What would be the matrix of the multiplication by I, for example? Well, what's our basis? Right. I guess it's the span of all things like x, y, I plus z, j plus w, k, right? So the matrix well, we can still talk about the matrix of multiplication by I would send I, well, it sends 1 to I, and it sends I to A, and it sends J to K, and it sends K, so does IK. We have to like IK would be I squared J, so it would be A J. No, you have to never use matrices and claim you are a true algebra Chad while simultaneously doing all relations that are basically the matrix method. You're right, I do have to claim I'm the true algebra Chad, and I will. But I won't not use matrices. Pretty sure there's a matrix on one of those first few pages of Weibel's homological algebra. What a beta. What an absolute sub beta male he is for that. Oh, for the cone maps, yeah. See, you gotta have a matrix for that. Yeah, I don't know. What am I trying to write here? No, we've probably got to use our brains to solve this one. That would be my guess. But the entries in his matrix are morphisms in abelian categories are the cool. Yes, exactly. We love matrices of morphisms. Okay, let's go back to the beginning and review some basic things. I guess we could try finding some filtration. No, but I guess this is simple. I guess this already is simple, so we're not going to find an interesting filtration. Yeah. But I guess we could, like, if we could necessarily force the existence of some order 2 things and try and choose those to be our basis elements. Simple filtration already done, yeah. If you pick any vector and start multiplying it by itself, wouldn't it generate those? Oh, possibly. Possibly. Yeah, we could start with E1. So E1... I'm trying to show that any 4-dimensional central simple algebra over a field is isomorphic to some quaternion algebra. But it's not clear how we would get, like... Well, let's see. So, I mean, E1 squared is just going to be, like, we could define X, Y, Z, and W to be the things that make this true. And then we could look at E1 cubed. So that'll just be E1 times all of this. And so we will then get X. Oh, this is going to get messy. The base field is any field. Any field. Yeah, this gets kind of gross quick though, right? Because this becomes X times E1 squared, right? Which I could write out, but then we also get Y E1 E2 plus Z E1 E3, or sorry, X Y X Z X W E1 E4. Yeah, not so clear. Not clear at all. But then, okay, let's see what happens if we go to E1 4. Then wait, why did I toss an extra X in all of these places? That was wrong. That was incorrect. This then becomes X E1 cubed plus Y E1 squared E2 plus Z E1 squared E3. Yeah, I'm still not, this is too gross to possibly be the right way to solve this problem. There could be something here, though. There could be something here. Yeah. E1 squared. What's the definition of a quaternion over a general field? Well, so you take two elements of the multiplicative group of your field, and then you define HAB to have to be, well, you define I, so I squared is A, J squared is B, and then this is the set of all X plus YI plus ZJ plus WK, where X, Y, Z, and W are in your field. And then you do the additions and multiplications you think you should. I don't know if it's too loud with that hair dryer going in the background. Hang on a second. So do you mind if I just, oh, yeah. Okay. We got to finish up pretty soon anyways. What he meant was not starting from the basis E1, E4, but just looking at 1, V2, V3. Huh? But what do you mean? Oh, 1. Uh, oh, I see. You take an arbitrary vector, um, an arbitrary vector, right? V squared and V3, right? And are these linearly independent? I think in general, no, right? Because what if it depends. Well, I guess if we choose, okay, so choose V, which is not in the span of 1. But wait, what does 1 mean here? Well, it's a central, yeah, okay. Yeah, wait, what does 1 mean here? Because it's just an algebra, right? So, so what does one even mean? I don't think that means anything, right? Like it's just a vector space with a oh, right, the algebra does have to have a unit. Sorry, you're right. Wait. No. I mean, an algebra is a vector space with a multiplication, and no, it does have to have a unit. Okay, I'm tripping. Straight up tripping right now. Yeah, of course. Of course it does. Of course it does. Okay. Anyways, I think the way to solve this problem is through theory, though. It has to be through theory. Right. You're right, Leo Lectures. You're absolutely right. We're showing that wait a second. Every central simple algebra is of this form, right? 4-dimensional central simple algebra. Yeah, we will need to use centrality somehow, of course. Let D be a division algebra. And consider this matrix algebra. One can show, this is what we're trying to show, that this is either a division algebra or isomorphic to this. So maybe we need to do something there? No, I guess not. Pick any you don't know any non-commutative algebra, but at least you can summon a quadratic extension. Yeah. Which, by the way, maybe that's... I still want to make... In the back of my mind, I want to make, like, a Magic the Gathering type game, but with math. Or somehow you summon theorems. I don't know how the mechanics would work. But somehow, like, I don't know, you play cards to try and build up proofs or something. KA should be a quadratic extension, so those would never be independent. Hello, Messaged. Then do the same with B in there. Maybe. I still feel like there's got to be some theory here. There's got to be some theory here. Like, yeah. Maybe if we look at the endomorphism algebra, we know that the endomorphism algebra is a simple algebra. This is modules over simple algebras, so I don't think the answer is here. Could we do per hour group nonsense? No, probably not. Oh, here we go. Central simple stuff. Oh god, I hope it doesn't use primordial elements. Then I refuse to prove it if we have to use primordial elements. Because K is central. That makes things work. So pick any element A not in K. And you think Ka should be quadratic? But I don't think... is that true, though? Is that true? Because why would it have to square to 0? I guess not square to 0, but why would it have to... So we choose some V not in K. And then V squared... if you can find if we can find an A not in K which is invertible, if it's not a matrix algebra, it has to be a division ring. So anything has to be an inverse. Can we just use that fact freely, though? I mean, he says that, but that's also an exercise to prove, right? Where is that? That's in the exercises somewhere. I mean, I think we just scrolled past that theorem a moment ago. Or that claim, anyways. Where was it? Because A will be K adjoin... will be a K adjoin A vector space. So it can't be dimension 3 or 4. But what are our assumptions on A? If it was dimension 3, it contradicts A being dimension 4. If it was dimension 4, contradicts K being the center. But how do we know that we're getting a degree 2 extension by adjoining this A? Like, certainly that won't be true if we just adjoin an arbitrary A, right? Yeah, what does K adjoin A? Like, why does A even have to be algebraic? What do you, just from definitions, I don't understand that. Why? But why? Why does it have to be degree 1, 2, 3, or 4? What's the proof? So we take a V here. Why would that have to be true? Think about 2 by 2 complex matrices, right? Over some field. Well, I guess in that case it does have to, each matrix satisfies its characteristic polynomial. So maybe that's not so crazy. But I don't know if we have an analogous theorem here. But K adjoin A will be finite dimensional since it is a subspace of A. Right. So take K adjoin A, by which we mean, I guess, the smallest. Wait a second. But wait, yeah, I mean, Arad, there can be a proper non-trivial subalgebra, because simplicity doesn't mean that there aren't any proper non-trivial subalgebras, right? Simplicity is more a condition on the ideals. So why would it give us all of K? I don't think that's necessarily true. Right? Simplicity is just a condition on the ideals / the module category. We can definitely have subalgebras, right? I mean, if we think about the ordinary quaternions themselves, you get the complex numbers as a subalgebra, right? You look at the think about the ordinary quaternions over the reals, and you look at the subalgebra generated by I, and you get the complex numbers. Yeah. Okay, so I'm with you now, Leo Lectures. We can definitely take K adjoin A, and yes, we can definitely take K adjoin A. And I think I agree with your dimension counting as well. It can't be 1 because A is invertible. Well, we don't know, but wait, we don't know that A is invertible. But I mean, I agree, this is going to be a vector space over K. And so we should have some dimension stacking thing. And so, I mean, since A is not in K. We know that this is not equal to K. And we know basically by dimension stacking, it can't have odd dimension. So I think the only possibilities are that either this has dimension 2, or it has dimension 4. Yeah. Just wanted to drop in and say my channel is so cool. Oh, thank you. I'm also glad that you found it. And yeah, I would say things are going well. Things are going well. Yeah. Okay, so where are we here? So why can't this be 4? Yeah, you've got this argument about the center. If it's all of A, then A's center is A. Right. And so that's false. So I don't even think we need the invertibility, right? I don't even think we need the invertibility. I think we know that that this is quadratic. Yeah. Might be even nicer to say, since K adjoin I cannot be a two-sided ideal, there has to be some J such that this is true. Is yet another element? K adjoin A could be that, which is not a field. Yes. I suppose that's true. Yeah, this thing doesn't need to be a field. I mean, I think our dimension counting still works though. Like our dimension counting. Oh, right. Wait a second. I'm still concerned about this one, right? Right. If KA right. Let's go back. It's not for I mean, yeah, okay, so wait. Yeah, this still applies, whether or not this is a field or not, because KA, this thing should be commutative. That thing should be, wait, is that, yeah, that's got to be commutative. So, yeah, you're right. Yeah, so this is fine. So I'm confident that is quadratic. I think we have that as quadratic. Or sorry, that I mean that yeah, that it's dimension 2. So KA, you're right, KI, but I guess you mean KA cannot be a two-sided ideal, right? But sure, I mean it has 1 in it, so it's not going to be an ideal. So what? So it can't be an ideal. So that means that there has to be some J such that when we multiply it, we land outside. Well, I mean, we know that there's something outside of this as well, right? I mean, ideal or no ideal. I have an idea for a new game show. Right, so we have 1, we have this element A now, and we can also just choose B. Maybe you choose B that lies outside of this thing, because we know it's dimension 2. And you're right, maybe I should call this I instead. I should call this J instead. Right? So now we choose 1, I, and J. But we need that I squares. Also, if A is not invertible, you don't see how to get rid of the dimension 3 case? I'm not sure I see why the invertibility matters though, because like suppose this were dimension 3. Oh, wait a second. I see. I see. Okay, I need to go. So I think we should come back to this tomorrow. And we'll try and work this out tomorrow. And this is also making me think maybe we should do some live stream group project or something. I mean, we've all kind of been working together as a group today anyways, and in general. So, I wonder, yeah, some sort of, maybe we try and read a paper together or something. I feel like our skill sets are all spread out, but yeah, maybe something to think about anyways. Something to think about. Okay, I'm going to end stream here. So go solve this problem for me and tell me the answer tomorrow in live stream.